Hey, we actually had a day of school. All right, you guys. It wasn't a snow day today. Very nice, or a cold weather day. So, math is awesome, and we're going to solve rational equations today. Okay, so we'll just pop right over to the next page, and here we have a couple equations we're going to solve. They have a bunch of fractions in them, more than just two fractions. So how can we solve equations with a bunch of fractions in them? What can we do? Yes, Dylan? Oh, Dylan's a pro at this stuff. All right, so we could get all the denominators to be the same. This is one way, one strategy of dealing with a bunch of fractions. So this is the way I like to handle this. And so I want to get a common denominator between all the denominators, in which case I'm going to write that over 1. What's a common denominator between 1, 2, and 3? Yep, least common multiple, 6. So now we're going to put everything in terms of sixths. That's hard to say. Sixths. So multiply this one by 2 over 2. Multiply 5 halves by 3 over 3. And multiply 4 over 1 by 6 over 6. And then I'm going to clean it all up. So when we clean it up, we have 2x over 6. That's the same as x over 3. Just looks different. Plus 15 over 6 equals 24 over 6. Okay. So now when we have everything over 6 and all the denominators are the same, and this is an equation here, this equation will be true when all the numerator stuff is true or equal. So what value for x, or values, will make the numerator stuff all equal? So you can kind of ignore the denominators at this point and just solve the numerator stuff. So 2x plus 15 equals 24. Okay, subtract 15 from both sides. I get 2x equals 9. Don't you hate when this happens? It doesn't work out like a neat whole integer. And you're like, crap, did I do something wrong? Oh. And then you go back and you look through it and you're like, well, I don't know. I think I did it right. And it's a test and you're like, oh my gosh, I don't feel like I did very well on that test. Ka-chow. X equals 4.5. Okay. All right, same thing, but a little different. I didn't have any variables in my denominators there, so I didn't really have to worry about the denominator being 0. But in this next one, I do have an x in the denominator. So just thinking ahead on this, there's one value that x actually can't be. What is it? 0. Good. So if our solution ends up being 0, that's kind of like a little bit of a situation, okay? Because it can't be 0, so it's actually not a solution. But we're putting the cart before the horse here a little bit. So let's go ahead. Let's get a common denominator between 3 and x. That's over 1. So a common denominator between 3 and x would be 3x. Multiply that one by x over x. The middle one by 3 over 3. And the last one by 3x over 3x. Clean that up a little bit. We're going to get 10x over 3x. That's the same as 10 over 3. Equals 12 over 3x. Plus 6x over 3x. Hey, what happened to Erin? Wasn't she here earlier? Oh, she has. Well, hi, Erin, if you're listening at home tonight. All right, solve the numerators. Okay, numerator stuff, what value for x will make the numerator stuff true? 10x equals 12 plus 6x. Get all the x's onto one side. I like to usually get them on the left. 4x equals 12 when x is 3. Okay, x is 3. I got to make sure, is that an acceptable answer? Does that make any denominators equal 0? Nope. They're all the same, of course. So 3 is okay. So that's the solution. X equals 3. Okay. All right, moving on up. This one actually, we've done these ones before. This is just fraction equal fraction, in which case you could always just do the cross products, right? Which cross products would be like getting a common denominator anyway, wouldn't it? Because what would the common denominator of x and x minus 5 be? It would be the product of both of those, x times x minus 5. So I'd have to multiply this one by x over x, which is what you would do if you cross multiplied, right? And I have to multiply this one over here by x minus 5 over x minus 5, which is what you would do if you cross multiplied anyways. Isn't that weird? Whoa. Okay, good. So now clean that up a little bit. I have 2 times x minus 5 is equal to 3 times x. That's going to be 2x minus 10 equals 3x, and x equals, what, negative 10. Is it okay to equal negative 10? Does that make any denominator 0? Nope, it's okay, so I can leave that. All right, what do you think? Let's do the, let's have this next one. Let's have you, I'm going to pause it. Let's have you do it. And then I want to see if there's anyone that's brave that wants to put the headset on and be the teacher. Well, there was no takers for wanting to put the headset on, so we'll just go ahead. You get a common denominator of x, right? So this is going to be multiplied by x over x. This one's going to be multiplied by nothing. This one's going to be multiplied by x over x. So after I clean this up and I get all the denominators to be x, I'm going to get x squared over x minus 18 over x. That one I didn't have to do anything to. And then equals 3x over x. All right, all the denominators are x, so we just got to make sure that we don't have a 0 as our answer. And we can solve the numerators. And this one's a quadratic, so we're going to set it equal to 0 and solve. So you get all the stuff on one side. X squared minus 3x minus 18 equals 0. All right, does that factor? Holy cripes, what just happened there? All right, this one factors. This one factors. We got x and minus 6 plus 3, I believe. Agree? Yep. Okay, now my solutions are going to be 6 or negative 3 unless one of those makes a denominator 0, which they don't. So my answers are x equals 6 or x equals negative 3. Ta-da! Pretty neat, eh? Yeah, who votes that's slick? 1? Just one person vote. 2, 3, 3.5, 4, 5. Last class, it was almost unanimous. You guys are losing your enthusiasm for this class. Pick it up. Okay, so the denominators, when they are equal to 0, if you find a solution, but it makes a denominator equal to 0, that's called an extraneous solution. Okay? It's kind of a bogus one. It's a fake solution. So here's the whole definition of that. So as we go through, we have to make sure that we don't have any extraneous solutions. So now I'm going to start doing some extraneous checks. This problem, let's just pretend that you didn't see that they had common denominators already, and you're like, oh, no, I'm going to cross multiply, and you might just look at that and go, yeah, cross multiply. That's what I did. So look at that, cross multiply. You're going to get x squared minus 5x plus 4. If you FOIL that out, and that's going to equal 2 times x minus 4, which is 2x minus 8. Get all the stuff onto one side. You end up with x squared minus 7x plus 12 equals 0. Factor that up. You're going to get x and minus 4 and minus 3. And so then your two solutions then are going to be 4 or positive 3. Or so you think. We have to now, this is what I was just talking about, now we have to check for extraneous. So we do an extraneous check. Extraneous answer means it's an answer that is not really an answer. It's kind of like a pseudo answer. So check 4. Does 4 make any denominator 0? Yes, it does. So you know what that's called? An extraneous solution. Cross it off. Forget about it. Okay, does 3 make any denominator 0? Nope, so 3 passes, 4 fails. So my solution then is just x equals 3. I can omit that 4 from the solution. You good? You want to try one? Should we move on to the next slide? All right, let's try it. We're back, and we solved this one, and we got this as our solution. And so what we did now is we did an extraneous check just to make sure that they don't make any denominator 0. And so we did an extraneous check, and both of these pass because neither one, when you put them in for the variable on the bottom, which is x, makes it 0. Okay, so we're good to go there. All right, moving forward. Oh yeah, we get into some better ones here. We're going to wrap this up here soon, but now we have some binomial factors in our denominator. So now it just gets to be a little more challenging as far as what is my common denominator. And so I like to put these parentheses around everything so I don't screw stuff up. So I'm going to put parentheses around all that stuff. Now, what is a common denominator between x minus 8 and 2? Can I factor x minus 8? Really? No. What about 2? I mean, not really. So there's no common factors. So the common denominator, or least common multiple, is going to be the product of those. So I'm going to multiply this one by 2 over 2, this one by x minus 8 over x minus 8, and this last one here by 2 over 2. And so the common denominator then is going to be 2 times x minus 8. And then I do have to multiply the numerator stuff out. Okay. Question?
But don't you have to, like, if you times it by 2, wouldn't you have to times everything by 2 then?
Like both sides of the equation? Not really, because look at, we're just multiplying this by 1. And you can multiply any individual anything by 1 because it doesn't change anything. It changes the way it looks. It's like 2/4 and 1/2. They're the same thing. They just look different, right? So it changed the way it looks, but it didn't change the value of the expression. So 2x minus 5 over x minus 8, that's the same as 4x minus 10 over 2 times x minus 8. And you have to multiply the numerator stuff out, but you don't have to multiply the denominator stuff out. Just leave it. X squared minus 8x there, I'll be adding that, and then 22 here. So now we just need to solve the numerator stuff, and we're good to go. Check for extraneous after that. So we have x squared minus 4x on the left side, and then we also have a minus 10 on the left, and if I move the 22 over there, it's going to be a minus 32 like that. And then I can factor that, hopefully. Looks like it factors x and x, minus 8 and plus 4. So my two solutions, and before I check extraneous, are 8 or negative 4. But I'll do a little extraneous check, and one of them is going to fail. Which one? 8. 8 is going to be an extraneous fail. So my only solution is x equals negative 4. Sometimes everything might fail, in which case if all your solutions fail, then there would be no solution. Yeah. All right. Same type of problem here, so I'll skip that for video's sake. And then the last page, we have, moving that. We have a situation where it's a little bit trickier to find your common denominator because we have to factor this stuff over here. So after you factor this to determine what your common denominator is going to be, you realize, oh, that they have a factor in common already, so this one just needs an x plus 4 over x plus 4. Right, so clean that up now. We have 16 equals 2x plus 8. As my numerator stuff, my denominator, I don't really care because I got them to be the same. So now I have, what, 2x equals 8. So x equals 4. And oh, look at what happened. Just what I talked about happened. X equals 4, do a little extraneous check, and oh my gosh, it doesn't work, you guys. Like, we have no solution for this. Oh my goodness. No solution. Who would have ever thought? Unbelievable. Okay. Last one. I'll leave up to you if you want to do it or not. 16-minute video. Not too bad. Get some work time here. And yeah, signing off.